So we're going to probably do a little bit more than the U sub today. My intention is to try to get you guys to the place that you can take the quiz next week as opposed to waiting into the following week. I think it's doable looking at what we're doing. Okay? So, and then when we come back, we'll review for that block day, and then you guys will take the test Thursday, Friday, is I think how that's going to go. Okay? All right, so thoughts on any of these? Would you want let's do this one first? U equals x plus 6. Du equals dx.
If you x minus 6, it's just going to be another. That means it's going to still be.
So you can also say that x is equal to u minus 6. Yeah?
Yeah.
Okay, so now we're integrating u minus 6 times the square root of u dx. Is everybody comfortable with this?
Oh, wait, you can multiply that.
Is it du?
You can multiply that.
Oh, that is du. Thank you.
Okay.
How does this help us?
You can multiply it out now. It's just
Like, I couldn't distribute the x into the square root sign, but I can Guys, Yarrow has COVID. He doesn't even have COVID. He tested negative, but he was exposed on Monday, and he has all the symptoms. So I'm wearing a mask because him, not because I'm sick, but it's definitely been a while. Like, we could think of it this way now, yeah? Which is what's useful. And then what? 5 halves u to the 5 halves minus 12 u to the 3 halves?
2/5.
Yeah.
You guys, that's what I wrote. Why do you guys always not see what I wrote down?
I don't think it's 12 either.
Oh, no, it would be times 3 halves times 2/3 is 2/3 times 6 is 4. Don't forget your plus c. And then go in. Cool. Okay, you guys, this one is not supposed to be secant to the x. It's supposed to be secant squared. Same with the one on the next down here. Both of those are supposed to be squareds. Okay. Hey, what do you think we should set as u? Tan x. Du would then be secant squared x dx.
Why is tan the u again?
Because what's the derivative of tangent? Because secant squared is that derivative.
Okay.
So are you saying you wanted to do u equals secant x?
I wasn't wanting to do that. I was just curious, like what.
Let's talk about it, because I think you could.
Okay.
Then du would be secant x tangent x dx, yeah?
Right.
And then
Oh, so
So like both of them, this is where it gets, this gets kind of interesting, right? So if I do this one, I'm going to have the integral of u du. And if I do this one, if I break that secant x into secant x times secant x, then I have a secant.
yeah.
Both of these. Do you guys see what I'm saying here?
Mm-hmm.
And so this would be u squared over 2 plus c, u squared over 2 plus c, which means we could call this solution tangent squared x plus c, or secant squared x plus c. Everybody with me? Does that bother you? Like, I look at that and I'm like,
That's what you have.
you guys feeling okay about this as we look at these graphs? So which one am I going to accept? Either one. They're the same. Okay?
I don't know where we're getting it from.
Okay. There are two ways to do the definite integrals here. Okay? So, if I gave you this initial question without us just having worked that, right? We might say, I'm going to stick with u equals tangent x. It feels a little bit simpler in my head, but it, you know, whatever's easier for you is the right one. Okay, you have two options on how you proceed from here. You could just integrate u du, get u squared over 2 plus c, which is then tan squared over 2, tan squared x over 2, evaluated from negative pi over 4 to 0. That's fine. That's a totally acceptable way to do it. The other thing we could do is say, hey, if I know that u is equal to the tangent of x, then I could say, well, what is u at negative pi over 4 and what is u at 0? Like I could plug my bounds into that u function. Everybody good? So let's see. Tangent of negative pi over 4 would be negative 1. Tangent of 0 is 0. Of u du. So you could change the bounds. And you're going to do u squared over 2 evaluated from 0 to negative 1. And that's a totally acceptable way to do this. There are times where I think this way is easier. There are times where I think this way is easier. Everybody good? Either way, we should end up with 0 minus 1/2, so negative 1/2. Is this okay? Very good?
Can you send her a form?
Yeah.
Okay, good.
Thoughts?
U what? Du equals dy.
Okay. Do you guys want to change the bounds or do you want to just solve it and then work backwards? Again, there's not a right answer versus a wrong answer.
Change the bounds.
So u of 0 equals 1, u of 3 equals 4. With this one, I feel like
So you could've
it's
done
kind of a,
-0 and then
I feel like it's a moot point on this one, which way you do it. So we would have what, 2/3 u to the 3/2, evaluated from 1 to 4. (16/3 minus 2/3). Again, if you didn't change the bounds on this, fine. And I'd argue whether or not you need to use u subs here, because du and dx are the same thing. It wouldn't make that huge of a difference. Okay, very good? Feeling okay about this? All right. Okay, you guys, do you guys remember even functions and odd functions?
Yeah.
Barely?
Not really.
It's when like either the reciprocal equals or like the negatives.
Oh, good. No, like shit. It's like
An even function is symmetric of the across the y-axis. Think of functions with even exponents. You with me? All right. And so, and then for an odd function, it's symmetric through the origin. Like y equals x cubed. Yeah? And if we know a function is an odd function or an even function, for example, if I was integrating x squared from -4 to 4, I could do 2 times the integral 0 to 4, because I know the area on one side is equal to the area on the other side. So there's some ways, if you know a function is even, to make things a little bit better. Also, if you know a function is odd, what's the area between two even sides going to be? 0, because you're going to have a negative and a positive of the exact same area. All right, so when we think about the function sine x plus cosine x, this is another one where I might choose to look at a graph of it real quick. Is this even or odd? No. So can we use those rules? No. Could you guys integrate this, though? Is this like a doable one?
Yeah. Without use of
Oh, could you separate this out into Could we do that? Okay. And this one is even or odd? Odd. This one is even. What do I know the integral of this is going to be? 0 plus. And then I might say 2 times the integral of 0 to pi over 2. The reason I might do that, you guys, is I feel like cosine of 0 is a lot better to calculate than cosine of negative pi over 2. It just makes the numbers a little bit easier to work with when we get there. How we feeling, okay? But overall, this is 0. Sine of 0, 0. No, it's not. It's negative 2. 2 times, and then we would have negative 1 minus 2. Because the integral of cosine is negative sine. Nope, it's positive. It's positive. It's positive. Now, is that easier than just solving it? Arguable, for sure. I would accept either. How are we feeling? You guys feel pretty good about these integrals? Yeah. What's up?
Isn't there like some like definition for like an even function? Isn't it like f of x equals f of negative x?
Correct.
And then the odd is like
F of negative x equals,
negative f.
yeah. All right. Then let's go ahead to go. Feels a little weird, right? That tangent squared plus c and secant squared plus c are the same thing.
Just because C is different.
So the chances are it's that the c's are different. But like as I look at that and I'm feeling like some discomfort in it, right? What if we real quick graphed tangent squared and secant squared? You guys see what I'm saying there? So
So the only difference is the Y. Yeah.
I'm sorry?
Yes.
I have it squared.
Because in the equation.
It's the final result.
Yeah, we're looking. So we're graphing both answers to see, does it make sense that tangent squared plus c and secant squared both plus c are both answers to the same question? You guys feeling okay? Just a different c.
So the C would account for that space at the bottom.
Yeah, they're just two graphs with, think of it as two graphs with different y-intercepts.
Okay.
Everybody good? Next page. Speaking of, you guys, after grading your quizzes, a lot of you technically got number 1 wrong, but I didn't mark it wrong. I will on the test, okay? Here's the deal. The integral of 1 over u is not natural log of u, it's the natural log of the absolute value of u. And if I didn't mark you wrong for not putting the absolute values there, but you technically would be wrong. Everybody good? You guys, what is the integral of 2 over x? 2 ln absolute value of x plus c. All right, what happens if I have 1 over 4x minus 1?
You could just, I think you can just think it through, yeah.
So the answer is 1/4 natural log of 4x minus 1 plus c. Now, if that 1/4 isn't intuitive to you, no big deal. You would say u equals 4x minus 1. Then du would equal 4dx. Du over 4 would equal dx. And that 1/4, that's where that 1/4 would come from. Either is fine. Okay? Thoughts on this one? So I would say, well, how about u equals x squared plus 1? What would du equal? 2x dx. So du over 2 is equal to x dx. So I have a 1/2 times the integral of the natural log of u du.
That's just
1 over 2 times, oh wait, yeah.
Or isn't it 1 over 2? Oh, you want to do the opposite.
Yeah, it does, but if you put it on the inside, it's fine. Now, in this particular one, if you had forgotten the absolute value and just put parentheses, I wouldn't care, because the value of x squared plus 1 is always positive. But it's really good habit just to put the absolute value there. Because you just like to prevent being careless in future problems. How are we feeling? What do you think? What would you do?
X, U is 3 cubed plus x cubed.
U equals x cubed plus 1, or plus x.
So you just get what that is.
This one you would definitely need the absolute value because it could be negative. We doing okay?
Oh. So you can have this one. So 2 U's. There should just be 1 U.
Hmm? Let's try it. Du would be 2x plus 1.
Oh, wait, never mind. Could you just separate x and x? That is like 2
Say that again. You guys aren't liking this one, huh?
U over U.
Yeah, but you can't just take out the x.
No, so hold on, could we do x squared plus 1 over x squared plus 1 dx plus the integral of x over x squared plus 1 dx? Could we do that? Does that feel okay? And if we did that, this is essentially the integral of dx, because x squared plus 1 over x squared plus 1 is 1. Plus the integral of x over x squared dx. Or x squared, I'm not saying what I'm writing. Yeah. My writing is better than my math right now. And since we just did this problem,
So knowing to pull out that 1/2, is that like it's just a rule we can like memorize, or do you have to like show it with U sub every time?
I mean, it's specific. It's kind of specific to this situation.
Okay.
Chances are, if you didn't if you did that, I probably wouldn't care as long as it was right. If you jump straight to the answer, I'd probably have a problem with it.
Right.
But like if you jumped to this step, I'd probably be okay with it.
Okay.
If there were bounds and you needed to show the change in bounds or something, that would be.
Sure.
Thoughts on this one? Huh? You want to multiply it out? Okay.
Then you gotta worry constant.
Is that going to work?
No.
I think we're going to run into a problem if we do it that way.
Can we do like the U, like rearrange it after we find what U is?
Okay, so continue with that, Sabrina.
Like, U is x plus 1, but then du is like dx, and then rearrange the U equation to make it so x equals U plus
Minus 1. Yeah. We're comfortable with that idea? I'm pretty comfortable with that. So how does that change things? Now we're going to have u minus 1 over u squared du. Yeah? I'm sorry? Nope. From here, I might separate this out into u over u squared du minus, and then 1 over u squared du. What's this one?
Natural log over u.
Natural log of u, right? Because it's going to become 1 over u. Minus,
Negative 1 over u, which is just plus the end. Plus c.
how are you guys feeling about that? Is that feeling okay? Because this is just u to the negative 2, right? So take it up 1, divide by negative 1. So final answer, the natural log of x plus 1 minus 1 over x plus 1
Plus c.
plus c. Nice, right? How are we feeling? Maddie, are you missing Monday and Tuesday?
Yeah.
Okay. What about you?
Just Tuesday.
Just Tuesday. Okay. You guys, what's the integral of sine?
Negative cosine.
Negative cosine. Integral of cosine?
Sine.
Do you guys remember from the other day the integral of tangent?
Oh.
What did we do? We said u equaled cosine, right? Du is negative sine u du, right? So we got negative times the integral of 1 over u. Oh, well, this is pretty funny. You guys, pick any variable other than u here.
You switch it for x this time.
Or, yeah, I used v just because of something we're doing later, but it doesn't matter, you know. And so we get negative natural log of cosine u. How would that change for cotangent? Everybody good? All right. Next, I would like us to find the proof for the integral of secant u. I'm going to give you guys about 3 minutes to think about it and see if anyone can get to it. Anybody get there?
The cotangent of secant.
I got natural log of negative sine of u plus c.
What did you get, Viv?
Cotangent of secant. I don't know.
Sorry,
I'm just
I mean
thinking 'cause
cosine
the
of u, cosine of u,
derivative
not
was secant.
negative sine. I accidentally plugged in du. Natural log of cosine of u. That's what I got.
Natural log of cosine?
Of u, yeah.
Wasn't that essentially, wouldn't that just be negative of integral of tangent?
Yeah.
Okay. You guys, if you were to go back and work those both and do the derivative, you're not going to end up with secant. Okay. So here's the deal. What you need to do, I'm going to show you guys the proof. This is definitely something you would be fine with memorizing if you wanted. Everybody good? What you're going to do is you're going to multiply this. It's not an intuitive step to do this, you guys. We're going to multiply this by secant u plus tangent u. So that we end up with secant squared u plus tangent u secant u all over secant u plus tan u du. Now, I would not expect you to come up with this proof at all, okay? Once you see it, you're just going to say, I'm going to memorize the rule. Miss Meister memorized this rule, okay? This is one of the few I would. So let's go ahead and say v, or any variable of substitution you want to use, I'm choosing v, is secant u plus tangent u. What would dv be? Well, the derivative of secant u is secant u tangent u plus the derivative of tangent u is secant squared u du. Do we see anything?
Yes.
The top is dv, yeah? Or so this becomes 1 over u du. That's what I said. Which is the natural log of v plus c, which is the natural log of secant u plus tangent u. Between now and tomorrow, I would like you guys to, using similar tactics, try this one. And then tomorrow we're going to start assuming we have this one. Everybody good?